In this LTS release of Node, there is an experimental but interesting module called Async Hooks. Async Hooks is designed to let you track the life cycle of asynchronous operations. So whereas before we used performance hooks to be able to log out at what time certain procedures were happening, Async Hooks lets you automatically understand when an asynchronous function is initialized. It'll tell you right before it gets called, right after it gets called, when it gets destroyed, or if it's a promise, when the promise gets resolved. So if you're trying to debug and figure out exactly when certain things are happening, or you just are unsure if some random library is calling some other function, you can use async hooks to track whether or not a certain function is getting called, when it's getting initialized, etc. When you're debugging, async hooks can help you pinpoint where an issue might be. So in our example, we're going to create a new file and then create an asynchronous resource, in this case a function that just has a set interval in it, and then add on a whole bunch of hooks that track the life cycle of that function. Let's go ahead and create that new file. I'm going to call it touch miscellaneous async hooks.js, and in this file at the top I'm going to say this is an async hook example. We're going to need two dependencies here. The first is async hooks, so we can call async hooks equals require async underscore hooks. But then we're also going to need a file system. And that is because, as you'll see, when you're tracking the lifecycle of asynchronous operations, you shouldn't use asynchronous operations to track them. And so for us, using console log is technically asynchronous. Although it happens really quickly, it is an asynchronous operation. So we don't want to log out the data using console.log. We want to use fs.writeSync, which will write to standard out in a synchronous way, basically do the same thing as console logging, but it will block the thread and stop anything else from executing. So the first thing that we need to do is define a target execution context. For us, we don't need one. We're going to define it as false. If we wanted to use the current context, we could pull it from the asyncs module there, but for right now, we don't really need an execution context. Now, I'm just going to write an arbitrary async function. So this function is going to be called what time is it? And it's going to take a callback. All it's going to do is define a set interval, and when that interval runs, it's going to call sf.writeSync1, which is just the syntax of write_sync, and then we're going to say that when the set interval runs, the execution context, so the current execution context that we're in when we are writing this message is, then we can state whatever it is. Async hooks dot execution async ID. We need to append a new line on the end. Then we're going to call back, and the thing we're going to call back is the current date. We're going to call this set interval 1000. So it'll execute once a second. Now we want to call that function. So we're just going to call what time is it and pass it a callback and expect back time, because once a second, this function is going to call back to us over and over and over again. So we're going to call sf.writeSync1, and then we're going to say the time is time, and then new line. Basically, we're just creating something that will have a whole bunch of asynchronous operations happening over and over and over again, and we'll log out what they're doing. We also, just out of curiosity, want to see what the execution context is at the moment in time. If you're confused earlier about defining an execution context, that will let you know what those are. Now we actually need to define the async hooks. So we're going to say that hooks is equal to an object, and it has a whole bunch of subfunctions on it. So init, which takes in async ID, type, trigger async ID, and resource. And within here, we just want to call fs write sync 1, and then say that the hook initialization happened, or rather the initialization hook got called, and we're going to attach the async ID that we got passed, and then a new line. So that is when whatever function we're tracking gets initialized. Now before gets called, it's only going to get past async ID. So we want to say hook before async ID. And these are going to end up in the console just so we can see which order things happen again. After is also going to get async ID. So we want to say hook after async ID. Destroy is going to get the same thing. So hook destroy. And then promise resolve, which for our case, we can log it out if it happens, but it really shouldn't happen because we're not using promises in this case. Lastly, we need to create a new instance of the async hooks module. So we are going to call async hook equals async hooks dot create hook hooks async dot enable. You might be wondering, why are we using fs.writesync all over the place? Well, that is because, as you've seen, we haven't actually specified which asynchronous resource is supposed to get tracked. All we've done is set up tracking for asynchronous resources. We need to minimize the amount of asynchronous functions that are happening in this file, otherwise we're going to get logging all over the place, because async hooks is going to track the lifecycle of all the asynchronous operations happening. So had we used console.log anywhere, every time console.log got called, it would automatically track the initialization of it, the before event, the after event, the destroy event, and the promise resolve. But since we would be writing the results of those events using console.log, the act of writing console.log would trigger more lifecycle events. And so we'd quickly end up in this spiral of events that trigger events that trigger events, and our system would soon crash. So I would advise to avoid using console.log anywhere in your file when you're using async hooks, but particularly within the hooks themselves, because if the hooks themselves trigger an async operation, you're going to end up in this recursive loop that will quickly run out of memory. So now that we have all of this set up, we can go ahead and start up this application, which is a fairly simple application and should just log out what the time is, but we'll also see the life cycle of this asynchronous function as it happens. So I'm going to call node miscellaneous async hooks.js. Looks like we just have a small syntax error here, and that is because we didn't actually close any of these open parentheses. So let's just close those, clear this out and try again. Async.enable has a little typo, so I'm going to clear that out and replace it with async hook.enable. One more time. All right, now we can see a whole bunch of things coming to the console one after another. Let me stop this and we can look more closely at it. We can see that during this set interval, the execution context is number 6. We have a whole bunch of hooks being fired because of various asynchronous things that might be happening elsewhere in this file, but we are particularly concerned about the execution context 6 because we're trying to, for example, debug what's happening with this set interval. For our purposes, we're just going to follow what is happening with 6. We're getting the before event firing, the after event firing, the before again, the after again, the before again, the after again. And every time the execution runs is in the context of 6. So that is how you go about debugging an asynchronous operation. Had we been actually destroying the operation or using a promise, these other hooks would have been called as well. The async hooks module is fairly complex. If you're interested in using it, you definitely want to read through the documentation in detail. It is also still an experimental module, and so your mileage will vary. In a few versions of Node from now, it should be a bit more stable.